Hello YouTube, this is an Arduino Nano that I've just purchased on eBay for about £3. Really cheap. This is my first ever Arduino. I've been programming PICs for ages, and this is a PIC. This little thing, I program them in assembler. You can program them in C. Assembler I think is easier, although it's much more complicated and it's not really an efficient way of doing things, although you can get your timings and everything perfect with assembler. But this is an Arduino. Comes in its own little board. Also get a set of headers that you have to solder to it. And first thing that took me by surprise was how small this thing is. It's tiny. If you compare this to a Raspberry Pi, see how small it is. Absolutely tiny, although it's not quite as small as a PIC, but hey, it's pretty good. So why would you use one of these instead of one of these? Well, the reason being, if you want to do something like I2C or SPI, you can do it on one of these using assembler, but wow, it's complicated. You have to set up addresses, you have to set up registers, all sorts like that. With this, you load in the Arduino IDE, and then you just literally a few lines of code, and you can do something. First steps first. Before we can use this, we have to first solder on all the headers. First thing you want to do is solder on the little in-circuit programmer header at the top of the board. I do it that way around because it's much nicer and cleaner to have it on the breadboard that way around, because your USB port's there and you've got your reset button accessible, and all this can be at the bottom. So I solder that on first. What I found useful to get it, make sure it's all lined up, is to put the headers all the way around into a breadboard. Do this to both of them, and then rest the Arduino on top with the pins going through the holes. So with your pins inserted into your piece of breadboard, or use VeriBoard for this. This is an old breadboard, so if it melts, it melts. Fit it on the top. Fit it on the top, and then solder the corner pins of each line, and then you can take it out and solder the rest. If you're like me, you're thinking, wow, that's great, so what do I do with it? I mean, what can this thing do? How do I use it? I mean, I've got this is brand new out of the box, just soldered together. When you plug it into the computer, you get some flashy lights. This is the bootloader in the actual device running. And then this is the default program it comes with. It's a flashy light program. Amazing. So how do I change the program? First thing you need to do is start your Arduino IDE, or Integrated Program Environment. Interesting. Program looks like this when it starts, and then in here we have loads of examples of different programs we can do. And say the basic one, Blink, is what everyone uses. This is the Blink program. So this is the Blink program. As you see, all we're doing here, we've got a setup routine, pin mode 13 as an output, basically saying turn pin 13, which is the pin where the LED is connected to, into an output pin. Simple enough. Then you have a loop routine, so this one, literally between the brackets here, will keep repeating itself over and over. So it's got digital write, because we'll be writing a digital 1 or 0, high or low. Pin 13 is a high. Delay, so we wait 1000 milliseconds or 1 second. Digital write again, pin 13, low, LED off. Then delay again, 1 second. Great, super. But how do I change it? Right, I've added a few lines of code, extra lines of code. So first thing I've done, I've changed this delay from 1000 to 100. So that's 0.1 of a second, or 1/10 of a second. So I also reverse these rounds, so that's now a low and a high. So we start off low for 1 second, then we briefly flash the LED high for 0.1 of a second, then we write it low again for 0.1 of a second, and write it high again for 0.1 of a second. So we should have a 1 second delay and then 2 very quick flashes. Little tricks, little traps that I found in writing in C. Everything is case sensitive. So if digital write, you've got a capital W there. If you were to make that a lowercase, it doesn't turn orange, and that won't work. That won't compile. It has to be a capital W. And as far as I can tell, you only find this out if you know it. And low, for instance, that all has to be capitals. If you write low in lowercase, nothing happens. It stays blank. You have to write it in uppercase for it to accept it. There's a lot of tricks like that. These are all on the Arduino website, how it was written. There's lots of information out there, but it took me a little while to work out that capitals were important in this, because writing in assembler, capitals don't actually matter. And to send it to the board, we click on the upload button. Click on that, have a compiling thing there, and oh, that's not very good. What happened there? Oh, another trap right there. Every line has to end in a asterisk. If it doesn't, it won't compile. So let's try running that again. So compile, and this time it's compiled. So that's now loading it to the Arduino, and we should see the little LED. There we go. 1 second delay, and then 2 fast flashes. So we're really good right now at making lights flash. But can we do anything sort of useful with this? You'll find online that there are lots of Arduino. If you just type in Arduino into eBay, there are lots of modules and things you can buy. And these are very easy to add to the Arduino. So this is one of them I bought just as an experiment. It was like £1 or £2. It really isn't much. And you see in the centre there, it's got HCSR04. Now if you type in HCSR04 on Google and then put in libraries, you'll find lots of code that you can add to your program on the computer to make one of these work really, really simply. So I've now built this board, and what this is a infrared, it's not infrared, is it? This is a ultrasonic range sensor. So one of these will send out a burst of sound. It will hit a wall or an object, come back into this speaker, and it will time how long that pulse has taken, and then the Arduino will display that. And I've set this up so that at certain distances, certain LEDs light up. So now I'm using this sonar sensor to trigger these lights. So as I move the object away from the sonar sensor, you'll see the lights turn off. As it comes back, it's closer. Turn off, and it comes back. So that's one of the things that you can do in Arduino. So it's measuring the time it takes for a sound pulse to bounce off this object, calculating it, and then putting it on LEDs. So the actual code for that is here. So this is the actual code. So we've got include ping library. This is what we found on the internet when you search for that part and then libraries. So we add that to our IDE. We set our trigger pins and echo pins and maximum distance we want this to work, and this is defined under that library. So all the information is there when you download it. And you got another here, which is this is how you set it up. So you got a new pin, new ping, sonar. Then you put your trigger pin, your echo pin, and your max distance in. Then we set up our pin modes again. So we set up pins 1, 2, 3, 4, all the way to 9 as outputs. Serial begin is just so that we can make sure this is actually working by going into up here, and then we can see active live. So as I move it, you'll see it will change. This is live data coming from the Arduino. So that's what it does. Serial begin, opens up the serial port. Then in our loop routine, we have a small delay to allow the ping to be sent and returned. So we serial print pings. This is the whole part of that, having it on the computer so we can see it all come out. So we tell it to print that. Then we tell it to do print sonar pings in centimeters. Again, this code is part of the library. Print centimeters, and then we digital write set all of our pins low, so we start fresh all low. Then we do an if statement, so if sonar pin centimeters is less than 3, we set pin 2 high. So if we're less than 3, pin 2 comes on. And then up here, if sonar pin is less than 6 centimeters, we set pin 3 high. And we go all the way down, doing exactly the same thing. You know, if it's less than 12, we set pin 5 high, less than 15, set pin 6 high, all this all the way down. And then that's it. Then the loop finishes and it goes back to the top. So we clear all the pins. So we set them all low, set them all to 0. Just turn them all off. Then we just carry it out again. Is it that, is it that, is it that, is it that? And that's all we do. We just keep repeating it over and over again. So this is the effect that we get. So as you move it back, as you can see, we'll turn off. Because the if statement is saying if it's greater than 12 centimeters or something, turn off these LEDs. And then as we go back, that statement is no longer valid, so it turns them back on again. So it doesn't turn them off. So there we go. Hope you enjoyed that video, and thank you for watching, and I hope to do some more videos with what you can do with an Arduino in the future.